The first part is definitions. And so just make sure yours basically looks kind of like mine. I try to simplify mine to a working definition that I can recall very quickly. The mole map, I gave that to you on your folder on your Schoology. Here it is written out, and it's just there to remind you how to go from one spot to the next spot. Okay? Then we looked at molecular mass and formula mass. I just want to remind you that molecular mass means that you're working with a covalent substance, and formula mass means I'm working with an ionic substance. Okay? So you can check yourself here. I went ahead and provided all of them, and you can see my work on the side. And again, just to check yourself, we're just adding up the parts off the periodic table. And that's how we get our numbers. And then we had mole calculations. These were strictly one-step calculations, just to get you going again on it. I left number 3 here. And so let's finish this one out. We have 13.45 moles of sodium. Sodium's mass off of the periodic table is 23. And yes, this is going to be a really, really large number. But, so our conversion factor is 1 mole of sodium equals 23 grams of sodium. And then we'll set it equal. And so we're simply going to multiply the 13.45 times 23. And we get 309.35 grams of sodium. And then we did our percent composition, which is simply part over whole. And one of the first things you have to do is you have to figure out what your formula mass is. Once you have that, you're simply taking each of your parts and completing it. So I left copper 2 hydroxide here, and let's look at this. Okay. So copper has a charge of 2 because I gave you the Roman numeral. Hydroxide is OH, and it's a -1. So we're going to criss and we're going to cross, and we get CuOH2. Now I need to add up my parts. So copper weighs 63.5. Oxygen is 16, but I have 2 of those. And a hydrogen is 1 times 2. And so I'll take the 63.5 plus 16 times 2 plus 2. And I'm going to get 97.5 grams per mole, or AMU, for it. Now I just need to do my part over whole, so I'll do copper over the CuOH2. I'll repeat this with every single one of them, but I'm just writing the first one for you. So we'll do 63.5 over 97.5 times 100. And we get 65.13% Cu. Then we'll repeat with the oxygen, which is 32 over 97.5 times 100. And that equals 32.82% oxygen. And it has to add up to 100. So we'll go ahead and do the last one. 2 divided by 97.5 times 100. and we get 2.05% hydrogen. And if I check my work, and I take the 65.13 plus 32.82 plus 2.05, it adds up to 100. And so we did this in class. We did empirical formulas. Basically, the trick is taking your percent and changing it to grams. Once I have that, then I'm going to convert my grams to moles, which is this step here. And then I look at the three that were given here, and I ask myself which one's the smallest number. And I'm going to divide everything by that smallest number. And I end up with C3H3O. So part 2 of this says if the molar mass of the compound above, the molecular mass of the compound above is 110, what's the molecular formula? Now, your empirical molecular formula can be the same thing. It just happens on this one it's not. And the reason I know that is because I go out to my periodic table and I find out what C3H3O weighs. And you take your 3 times 12, which is your carbon, plus 3 times 1, which is your hydrogen, plus 16, and you'll get 55 grams per mole. So then all I have to do is figure out how many times 55 goes into the 110. So 110 divided by 55 is 2. Now I just simply multiply my formula by 2, and I get C6H6O2. Now we'll go forward with types of equations. I had you putting types of equations on there, and then also states of matter, and then balancing. I left one down here. Let's go ahead and do this one together. So I have zinc, and I'm relying on your lab experience for this. So more likely you'll be working with solid zinc. So we'll say zinc solid plus, we need our formula for iron 3 chloride. So iron is a positive 3 charge because it has a Roman numeral 3. And then chlorine is a negative 1. So when I crisscross, I get FeCl3. So FeCl3, and we're going to call this aqueous because it's combining with the zinc. And that's the only way I can get those two combined. So it's going to yield zinc chloride plus iron. Okay, so now we got to know what charge zinc is. And if you look it up, zinc's going to be a +1. Chlorine is a +1. And so we're going to crisscross. Sorry, zinc is a +2. I had to check myself on that. So zinc is a +2, chlorine is -1. We're going to crisscross that, and we get ZnCl2. And we get iron out by itself. So the iron's going to be your solid. This is going to be your aqueous. Okay. And now the last thing we have to do is go to balance. Okay. So zinc, I got 1 and 1. I got 1 and 1 iron, but I have a different number of chlorine. So to get my chlorine to balance, my least common multiplier is a 6 between those two. So I'm going to make this FeCl3 go to a 6. So I'm going to put 2 out front. As soon as I put 2 there, boom, I got to put 2 from the Fe. And now to make this chlorine go to a 6, I've got to put a 3 out front. And if I do that to that side, then I got to put a 3 there, and I'm done. So the last question is what type of reaction this is. Well, I've got zinc here hanging out by himself, and I got iron over here by himself. So this is a single replacement reaction. All right. I also saved one on the stoichiometry. And And so what mass in grams of aluminum iodide is consumed with 46 grams of HCl2 is produced? So we'll start with our 46 grams of HCl2 and we'll place over 1. Now, since I've already worked some of these problems, I already have what the mass of HCl2 is. And we did this earlier today down here in the red. And so HCl2 weighs 454.6. So since mass is on top, we're going to put it down on the bottom next. 454.6 grams HCl2 equals 1 mole HCl2. I do expect you to label your units. Now the next step, I go back to my balanced equation and I look at my HCl2 and I see that I've got 3 moles out front. So I'm going to write 3 moles HCl2 because I need to cancel those units. And I'm going to go to aluminum iodide and it's got a 2 in front of it. So 2 moles AlI3. Now, I need to finish this out. So I'm going to put 1 mole of AlI3 and I'm going to go find my mass, which I did earlier, which is 408. I'm going to convert that over real quick. 27.55. And so it's 27.55 grams. And I need to round that up to 28 grams H of AlI3 because my mass was given without a decimal. Okay, so we did our theoretical yield. Remember, theoretical is your max. And then we did percent error. So I'll do one more with you on this one. Sarah measured an undergraduate cylinder, 4.5 milliliters. The accepted value is 5. So we have 5 minus 4.5. Those are absolute value bars divided by 5 times 100. And so when we calculate that, we get 10% error. Now, those of you who are in class today, I talked about the fact that electron configuration, we seem to be a little rusty. So as far as this first test goes, I'm not going to have electron configuration on your test. Okay? And we'll keep practicing that. That's going back to your SPD and F. Okay? Periodic table trends. You have the chart. It has those trends on there. Just always remember, we're talking about atomic radius. We're always going to go, francium is going to be your largest atomic radius, and then the opposite quarter will be smaller. Affinity and electronegativity. Affinity makes the bonds, is the ability to make bonds. Electronegativity is referring to the property of that atom and the charge it has. A difference in core and valence electrons. Core, they are shielded electrons, and they're going to play a role on properties of the element. Valence electrons are bonded, so those are the ones that actually will be interacting with the environment. Last thing is your atomic structure, reminding how to read those periodic tables. So I went ahead and just highlighted some things that your number of protons and your atomic number have to be the same number, and that the atomic mass is equal to atomic number of protons and neutrons added together. Generally, your protons equals your electrons, but if you notice on the second one I have Li plus, you cannot change your protons and increase that to 4 because that would change it to beryllium. So my proton stays the same. I either lose or gain electrons to get that charge. Okay, that is it. That's what we worked on, and I hope that helps.